Okay, now so far, when we've been looking at complex numbers x plus yi, we've been basically drawing them on as Cartesian coordinates, xy. So point P here, the complex number, is xy. However, that is the Cartesian that's as Cartesian coordinates. However, complex numbers can be written also in a polar form, and that's also called the modulus argument form. So the point P in the Cartesian equation with coordinates xy, which is x across y up, can be represented in terms of polar coordinates r theta, where r has to be greater than 0. Now r is the length, where r is the length of your, basically your vector OP, okay, if that's your point P, it's the distance from the origin to your point P, and theta is the angle from the positive direction of the x-axis to the ray OP. Just like theta is always the angle in the positive direction from the x-axis whenever we've been looking at trigonometry. So if we can therefore draw up a right angle triangle, if this is x and this is y, this length here is defined as r and this is the angle theta. Let's look at cos theta. Now cos theta is x on r, okay? So cos theta is x on r, therefore x equals r cos theta. Now sine theta is y onto r, on r, so therefore y is equal to r sine theta. Now, if we look at Pythagoras' theorem here in this right angle triangle, r squared equals x squared plus y squared, and so therefore r is the square root of x squared plus y squared. So therefore now, the Cartesian form of the complex number z equals x plus yi can be represented in polar form. We know that x equals r cos theta and y equals r sine theta. So if we've got z equals x plus yi, replacing the x with r cos theta and the y with r sine theta gives us z equals r cos theta plus r sine theta times I. We can see that r is a common factor here, so we pull it out. So that is equal to r bracket cos theta plus I sine theta. Now there's an abbreviation for cos theta plus I sine theta, and that's called cis theta. So therefore z equals r cis theta, where cis theta is equal to cos theta plus I sine theta. So cis theta is just a quick way, an abbreviated way of writing cos theta plus I sine theta. So therefore the polar form of complex number is z equals r bracket cos theta plus I sine theta, which can be abbreviated as r cis theta. Now, that's the polar form of a complex number. Now, two other definitions: the modulus and argument of your complex number. Now, the definition for modulus of your complex number z, or it's also called the absolute value of z, is defined as the distance from the origin to the point representing the complex number z. So the modulus of z is this distance r, okay? So it's the distance from the origin to the point representing the complex number. So it's this distance here, so it's r. We know from here that r is the square root of x squared plus y squared. So you need to know, if you're asked for modulus of z, it's that distance there. So modulus of z, it's written in abbreviation as mod z. It's also called the absolute value of z. So we've got absolute value of z. Now we know that z equals x plus yi, so that's defined as the absolute value of x plus yi, which is this distance here r, which we know is the square root of x squared plus y squared. Okay, so therefore modulus of z, or absolute value of z, is r, which is the square root of x squared plus y squared, okay? Because we know that r squared equals x squared plus y squared, therefore r is the square root of x squared plus y squared. This distance is called the modulus of z. Now, that's the modulus of z. The polar angle theta, so this angle theta has a unique name, and it's called the argument of z, and it's abbreviated ARGZ, or it's also called the phase of z, or the amplitude of z, or the angle of z. Now, this argument of z is this angle theta plus 2n pi, so it's where n is a positive integer. So for example, n could be 1, so it's theta plus, if n was 0, you just get theta. If n is 1, you would get theta plus 2 pi. So theta plus another revolution takes you back to the same place. If n is 2, you get theta plus 2 pi. Sorry, I'm not sure if you know yet, but pi is equal to 180 degrees. So therefore 2 pi is 360 degrees. Okay? So you just need to know that. So note that argz can take on many values, since multiples of 2 pi or 360 degrees is added onto theta. But it is exactly the same spot every time. Now, that's the angle theta is called the argument of z. Now, there is another definition that you need to know, and it's called the principal value of the argument. Now, notice this argz has a small a. So argument of z doesn't have a capital A. Principal value of the argument has a capital A. Now, this value of theta obviously can go anywhere from 0 all the way to 360. But sorry, you can't see that. You can't see that. But if I draw a number plane, we know 0 to 180 is there. So what we do, if we want to name the principal argument, we don't go 0 to 360. We go 0 to 180 and we stop, and we come back here and we go 0 to minus 180. Okay? So therefore, the principal argument of z is defined to be the angle where theta lies between negative 180 and positive 180, or negative pi and positive pi. That still is a complete revolution of 360, but we're going from 0 to pi, or we're going from 0 to negative pi. Okay, remember pi is 180 degrees. 0 to 180, or 0 to negative 180 with negative angles. Here, anticlockwise is positive angles. So just keeping that in mind, principal argument of z, capital A, equals argz with the capital A equals theta, where theta must lie between negative pi to pi. Now, when you're asked to find the argument of a complex number, you must give the principal argument. So you can't give an answer of 2 pi or 3 pi on 2, 1.5 pi. You can't do that. It's got to lie between negative pi and pi, or between negative 180 and positive 180. It's really important that you remember this, that it lies between negative pi and pi, otherwise you'll end up losing a mark in some question. Now to page 20. So therefore the polar form of a complex number, or now the polar form is also called the modulus argument form. It is r bracket cos theta plus I sine theta, which is r cis theta for abbreviation, and the Cartesian form of a complex number is z equals x plus yi. Okay, so you need to know the difference between those two forms. Okay, now example, express the following in modulus argument form and sketch on an Argand diagram. Let P, which is xy, represent z, your complex number, which is x plus yi, on the Argand diagram, where z has modulus r and argument theta. So we're going to start with the first one, 2 plus 4i. So I'm going to sketch it here. We know 2 plus 4i is here. There's 2, there's 4. Remember, we're going to draw a right angle triangle. Here's my theta. This is my r. This distance here is 2. This distance here is 4. This is a right angle. Okay? So we know that, I don't have to put this 2 here and there. So we know that r is the square root of 2 squared plus 4 squared. Okay, because r squared is 2 squared plus 4 squared. So therefore r is the square root of 2 squared plus 4 squared, which is the square root of 20, and simplifying that, we get that r is root 4 times root 5, or 2 root 5. And the argument is we're trying to work out theta. So using sine, cos, or tan, we use tan. Tan theta is 4 on 2, which means that tan theta is 2. So therefore, theta is tan to the minus 1 of 2, which is, on your calculator, tan to the minus 1 of 2. We're just going to do this in degrees at the moment, which is 63 degrees 26 minutes. So that's what theta is. So therefore, your complex number z, we know z in polar form or modulus argument form, it's written as r cos theta plus I sine theta, or r cis theta. So therefore, z is r, which is 2 root 5. So it's 2 root 5 cis. This is theta. 63 degrees 26 minutes, but that really is the abbreviated form. So z, your complex number, really is 2 root 5 cos 63 degrees 26 minutes plus I sine 63 degrees 26 minutes. So that's your first one. Okay, now let's look at the second one. Negative 2 plus 4i. So I've got negative 2 here plus 4i up there. So I'm going 2 across, 4 up here. Now, remember, negative 2 plus 4i will be in quadrant 2. Remember, the angle is always taken from the positive direction of the x-axis. So here is theta. So we know that this is r. So r is, again, just the square root of 2 squared plus 4 squared, which is the square root of 20, which is 2 root 5. Now we know that this angle here from before in here is 63 degrees 26 minutes. So therefore our theta here is 180 minus 63 degrees 26 minutes, which is 116 degrees 34 minutes. And so therefore our complex number z in this case is 2 root 5. I'm not going to write cis, I'm going to do the expanded form, cos of 116 degrees 34 minutes plus I sine 116 degrees 34 minutes. So remember, it's r bracket cos theta plus I sine theta. Don't forget to put the bracket. Here we can see that we're clearly in quadrant 2. Okay, obviously it's not going to be this point here is different to this point here. This is why this one is in quadrant 1. You've only got 63 degrees 26 minutes, but this point in quadrant 2 is 116 degrees 34 minutes. Notice that theta, we know, must lie between pi and minus pi, or minus 180 and positive 180 degrees. Okay? Okay, this next point here, minus 2 minus 4i. So minus 2 minus 4i looks like we're in quadrant 3. Now, we cannot say that theta goes all the way around there because that's bigger than 180. So theta has to go here. This is my new theta. Okay. Now, I know that this little bit here in there is 63 degrees 26 minutes. So therefore, again, we know that r is 2 root 5 from all those previous questions. It's the square root of 2 squared plus 4 squared. But my theta, this angle here in the negative direction, is negative 116 degrees 34 minutes. Because I know that this bit in here that I'm pointing to, that little bit in there is 63 degrees 26 minutes. Because it's the same right angle triangle every time. And if you weren't sure, I can call this alpha or something. Tan alpha is 4 on 2. And again, you'll get 63 degrees 26 minutes in there. This is going in the negative direction. So this will be negative 116 degrees 34 minutes. So therefore, the complex number here is z equals 2 root 5 cos of, and put it in brackets, negative 116 degrees 34 minutes. So when the angle's negative, put it in brackets, plus I sine, in brackets, negative 116 degrees 34 minutes. And just stop there, okay? Now, for this last one, 2 minus 4i, notice you have to sketch them, otherwise you don't know what quadrant you're in. 2 minus 4i is down here. Again, 2 across, 4 down, there's my angle. and from the positive direction of the x-axis and going clockwise, it's a negative angle. I know that this is r, that was r. Again, r is going to be 2 root 5, exactly the same again. But the angle this time is a negative 63 degrees 26 minutes, because we know that the angle in the triangle is 63 degrees 26 minutes from previous questions. So therefore, z, your complex number here, is 2 root 5 cos of negative 63 degrees 26 minutes plus I sine negative 63 degrees 26 minutes. Okay, so that's I sine negative 63 degrees 26 minutes. Okay, so that's just, you won't be asked to do all four, but I'm just showing you quadrant 1, quadrant 2, quadrant 3, quadrant 4, all with 2 and 4. Some of them sometimes positive, sometimes negative. They've all got the same modulus of 2 root 5, same length of that bit there. The angle inside the triangle is always the same, but we're just sitting in different quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, and that's indicated by the angle that you can see as well. So, example 2, express the following in modulus argument form, negative 1 minus I. You have to draw it first, otherwise you can't do these questions. So negative 1 minus I, might want to make that a little bit big. So negative 1 minus I is down here. This point here is negative 1 minus I. But in the right angle triangle, that's 1 unit and 1 unit. Right angle there, this is R. Remember, R is the square root of 1 squared plus 1 squared, which is the square root of 2. And here, I'm just going to put this, I'm going to call this angle here alpha. Okay, now tan of alpha is 1 on 1, which is 1. We all know that tan of 45 degrees is 1, so alpha is 45 degrees. But that is not my my argument, or my principal argument is the angle from the positive direction of the x-axis. But this is going in a negative direction. I can't go around like this because it'll be bigger than 180. So therefore, my argument of z, okay, is negative. I can go negative 180 plus 45, because that little bit in there is 45. So it's negative 180 plus 45. In other words, it's negative 135 degrees. If that's 45 degrees, this is 135 degrees, going in the negative direction, so it's negative 135 degrees. Okay, so I'll just draw that again. Basically what I've got here is that if that's 45, this here is negative 135. This is a right angle, 1 unit, 1 unit. Now, so therefore, my complex number in, that's Cartesian form, negative 1 minus I, in mod arg form or polar form, it's r, which is root 2 bracket cos of negative 135 plus I sine negative 135 degrees. Okay, now that can also be written, so that's in degrees, but we have to learn to write it in terms of pi. Now 135 is, well, 45 degrees, so we notice that 45 degrees is pi on 4. 135 degrees happens to be 4 times 45, which will be 3 times, sorry, it's 3 times 45, which is 3 times pi on 4, which is 3 pi on 4. So I can also write this as root 2 cos negative 3 pi on 4, because negative 135 degrees is 3 pi on 4. So negative 135 degrees, this angle is negative 3/4 pi. Remember, this is 0, negative pi. This is negative pi on 2 when you go 90 degrees. So plus I sine negative 3 pi on 4. Okay, so that is now written in Cartesian form. This here is mod arg form, both in degrees and radians. Okay, now radians means in terms of pi. Now to page 121. Oh, sorry, 21. Now looking at 4 plus 3i. So again, sketch it. 4 across 3 up. 4 across 3 up. Here's my theta. That's my r, okay? I've got a right angle triangle. So remember that r equals the square root of 3 squared plus 4 squared, which equals 5. Square root of 25, which is 5. And tan theta equals 3/4, so therefore theta is tan to the minus 1 of 3/4, which is 36 degrees 52 minutes on your calculator. So, therefore, 4 plus 3i, which is Cartesian form, in mod arg form, can be written as r bracket cos theta, which is 36 degrees 52 minutes, plus I sine 36 degrees 52 minutes, or I could write that as 5 cis 36 degrees 52 minutes. That's in abbreviated form. Or if I want to write it as an exact angle, I would write it as 5 bracket cos tan to the minus 1 of 3/4, but you won't normally do that, plus I sine bracket tan to the minus 1 of 3/4. Not tan, yes, that's right. So that last one is as an exact value, whereas this 36 degrees 52 minutes has been rounded off. Okay, now for example 3, it says if k is a positive number, write z in modulus argument form in terms of k if z equals k. Now, if k is a positive number, so if we've got z equals k, that is only real, there's no imaginary part. So k, okay, so if k is a positive number, so k might be 5. So I've got that my complex number here is z equals 5. Well, it's not really complex, it's only real. So here is 0. So therefore, r is this distance here. I can see that, so therefore, r, what's the length of r? Well, it's k units. What is the angle if I was to draw up a right angle triangle? Well, I don't have any angle from the positive direction of the x-axis. So therefore, sorry, I'll write argument of z equals theta, which is 0. So therefore, if I write z in mod arg form, it's going to be z equals, remember it's r cos theta plus I sine theta. Well, what does r equal? It equals k, and the angle is 0, so it's cos 0 plus I sine 0. Now we know that cos 0, if you draw a cos curve, I'm just going to do that quickly up here, cos 0 is 1, that's the cos curve. Sine 0 is 0. And if I just work out what that is, so this is my answer. This is my answer. Z equals k bracket cos 0 plus I sine 0. But if you just look at that, cos 0 is 1, sine 0 is 0, I end up with k. Z equals k, which is what I started with. So yes, this is my answer here. Okay, this is just checking, and it was correct. Okay. Now, z equals negative k. If I was to sketch that, remember k is a positive real number, so negative, say, let's say k is 5, negative 5 would, say, be over here. So let's represent this as a complex number. So this is x, this is y. Remember, the angle theta goes from the positive direction of the x-axis. And r, here is my complex number, r equals negative k, and the argument of z is theta, which happens to be, sorry, positive 180 degrees. So therefore my complex number z is equal to r, which is negative k, cos 180 plus I sine 180 degrees. Now you always would mention, I mean, I know this is 180 or minus 180, but 180 is the simplest, is the simpler form of between the two, between 180 and minus 180, okay? Or I could write it as z equals negative k cos pi plus I sine pi, which is written in terms of pi instead of degrees. So it's in terms of radians instead of degrees. Now, if I was just to check that, cos of pi or cos of 180, looking at that cos curve, is -1. And, sorry, I'm sorry here. R is always positive. Sorry about that. So it's just K, okay? R is that distance. Remember, it's the square root of x squared plus y squared. So if I just do it here, or R is, if we look back a few pages before, modulus of Z, sorry, can you see that? I'm not sure. Modulus of Z is always positive because it's the absolute value of Z, absolute value of x plus yi. R is the square root of x squared plus y squared. So this R has to always be positive. So R is the absolute value of -k, which is k. So if you can fix that, this is positive. Okay, so there's nothing there. So it's k times cos 180. So the theta being 180 is what brings it over there. Okay, so it's k times cos 180 plus I sine 180, or k times cos pi plus I sine pi. Now, if you look at cos 180 here on the graph, cos 180 is -1, and sine 180 here is 0. So, and k times -1 is -k, and therefore that is checked. Okay? Now, looking at z equals ki. If k is a real number, a positive number, then ki would lie up here. So what's this distance here? It's r. There's the origin. There's your angle from the positive direction of the x-axis. Now we can see that r is, this axis is y or yi. This, I can write it as ki, but that distance there is k. So r is equal to k. Theta, we can see here, is 90 degrees, or pi on 2, because 90 is 180 divided by 2. Therefore, your complex number ki, z here now equals ki, which is modulus r, which happens to be k, cos of 90 degrees plus I sine 90 degrees, which is k cos pi on 2. You really should be writing it in terms of pi's, not degrees, okay? Plus I sine pi on 2. And let's just check our answer. What's cos of 90? Well, up here, there's the cos curve. Cos of 90 is 0. So it's k 0 plus sine of 90 is 1 plus I times 1. And that's why we get k times I, which is ki. So that's my answer. But this is just checking. And sorry. So k cos of 90 plus I sine 90. Cos of 90 is 0 plus I times sine of 90 is 1. So we get k times I, which is ki. So therefore that is correct. And the last one, if z was minus ki, where k is just a positive number, so we've got, say, minus 2i or something, or minus 5i, it's down here, minus k, I or minus k. This distance here is r. Well, that distance there is the absolute value of -k, which is k. This angle here always has to go from the x-axis. That's my theta. My theta here is -90, which is -pi on 2. So therefore, your complex number minus ki, or in this case, it's purely imaginary. Remember, it's r, which is k, cos minus 90 plus I sine minus 90, which is k cos, in brackets, k bracket cos minus pi on 2 plus I sine minus pi on 2. Now, what we can do here is, oh, actually, I'll just leave it like that. So cos of -90, I mean, you can just do that on your calculator, or if you look at the cos curve, -90 is back here, because see, this is 2 pi or 360, and that's pi, and this is -pi. So that's the cos curve. cos, and this is negative pi on 2. Cos of negative pi on 2 is 0, plus sine, if I drew the sine curve and continued there, this is negative pi on 2. Sine of negative pi on 2 is negative 1. So therefore it's k times negative 1, which is negative k. Sorry, and there's an I there too. So it's I times negative 1. So negative 1i. So it's negative ki. So that's checked. But this here is my answer. Okay? K cos negative pi on 2 plus I sine negative pi on 2. Okay, and that's the end of page 21. The next video starts from page 22.